Morning students, welcome to Digital Design Lab 4. First three experiments we did on 7.4 series digital ICs using LT Spice. Now I'm going to introduce you to Verilog code based experiments and we'll implement it in Xilinx ISE. Those who have got Windows Professional with you, you can go to this link and then you can download the installation files for Xilinx. Okay, once you unzip that folder, you will find install xsetup.exe. You just run it, so it will install a virtual machine, and you will get an small uh, shortcut named ISE. Okay, so you got to trigger that ISE to get into Xilinx. Okay, those who have got Windows Home Edition, okay, you need to download this file, Xilinx ISE for Windows Home, right? Again, you got to run the setup, right? But here in this case, you got to make some choices. I'll let you know what are those choices. So specifically, it will ask for the edition to install. So you got to select ISE Webpack. Okay, those are good Windows Home. So once you have, then it will keep running. It will take close to 30 to 40 minutes. Towards the end of half an hour or so, or towards the end of the installation, around 30 to 40 minutes, it will ask for key in the license key. So this window would pop up, license configuration manager. Okay, so you got to select locate existing license, right? You got to select that, and once you select that and press next, okay, it will ask you to copy the license. So you click on the copy license and you can browse. So in the folder which I have asked you to download, there will be one file named as xilinx.lic. LIC stands for license. So you got to browse and select xilinx.lic and then press next. So that will install Xilinx software for the Windows Home Edition. Okay, so just try out this. In case you have any problems, feel free to get in touch with me on my mobile or through mail or WhatsApp, whatever is comfortable to you. Okay. So today we are going to do gate level modeling. Gate level modeling simply means that we are going to use gates. Now we are going to define what are the inputs of the gates and what are the outputs of. There are other words of modeling also, like data modeling, which I'll explain you in the next lab. Okay, I don't want to confuse you with lot of modeling. This being the first Verilog A code, just understand here we are going to specify the gate level modeling. I'll tell you what are the other kind of modelings available and what is the difference in the next class. Okay, so this is what we are going to implement. I am going to demonstrate this simple circuit. I am going to explain you the code and also I am going to demonstrate in ISE. Right. So this is like what we are going to do is A B. Okay, the function is A B or C naught, right? C bar. Okay, so this is the gate. So when we write a function for say for gate 3, so each gate we need to give a specific name here, right? When you write the code, so this G1 stands for the gate 1, gate 2, and gate 3. So we need to give names to these gates, and also if there are some intermediate wires which we are going to use as input for the next any gate, so we need to write. So here to this we have already named this wire as Y, which is an output, whereas this wire, this is going to be as an input to gate 3. So there is no name to this, right? So we need to give an intermediate wire name, which I have given here as Y1. So if I see the code, this is how the code would look like, right? First you write module simple circuit. This is the name of the simple underscore circuit is the name of that particular module, right? So simple circuit is the name of the module. There are three inputs: input A, input B, input C. Okay, you can also write input A comma B comma C. That's also fine. There are two outputs: output X, output Y. Again, you can write output X comma Y also. And also we need to define one wire, right? This is intermediate. So this is not available outside to see, okay, in the module, but internally we are going to define one wire, that is W1. Okay, so this is the simple code which we write. And gate 1, right? So and gate G1 means gate 1. Okay, you always have to give this. So students do make a mistake of not writing this G1, G2, G. Even if you see, you can use n number of gates, so each and gate will give, each gates will give some number. So if you write just and in bracket this thing, it will show up syntax error. So every gate which you use should have a unique name. It could be G1, G2, A1, A2, B3, B3, whatever, but it has to have some names, right? Okay. And this is syntax for an AND gate. Okay, for all digital gates, what we are going to use, it will be output followed by inputs. Okay, so a G1 gate is W1 is the output, and A and B are the inputs. Okay, and NOT gate is the G2 gate, which Y is the output and C is the input. And then there is a OR gate, right? OR is XOR of OR is gate 3, which is OR of W1 and Y, right? So this is the code which we have to write, and then we'll have to run and test it. Okay, so this I am going to demonstrate for you. What you have to do it yourself is to make a 3-bit majority carrier. Okay, which we are already done in hardware. Now the same thing, 3-bit majority carrier and 3-bit parity encoder. These two you are going to implement it in Verilog of your own, and you will show it in the next lab for assessment. Okay, this is a take-home assignment. If you want to practice it yourself also, you can do binary to gray and gray to binary, both you can do, right? So let me go to the demonstration section. Okay, I have installed the Xilinx software. I'll get something known as Project Navigator. I'll get Project Navigator for Windows Professional. Those are using Windows Home. You will get an ISE. Okay, it will be something this yellow kind of folder and ISE. Okay, you might get a shortcut of Xilinx also. So that is the not the one which you got to use it. You got to use the Project Navigator for Windows Professional and ISE for the Windows Home Edition. So I'm clicking Project Navigator out here. So it will take 2 to 3 seconds for it to start. Okay, I can close these. It will take me to a virtual machine. It will just take 2 or 3 seconds to initialize. For the Windows Home Edition, you'll not get this because it will run on Windows. It will not run on a virtual machine, so you'll get a slightly different one. But once it starts, both are to be exactly the same. Okay, once you initialize Xilinx, okay, you will get this desktop here. So the first and fourth thing, I'm going to create a folder where all my work will be saved. Okay, I'm calling it Sanjay by my name. I've created a folder, so all my work will be saved in this folder. So I have first thing I've done, I've created a folder named Sanjay. So I'm going to now trigger Project Navigator. So it's right. So this has opened up a new window. Now I'm going to start a new project. Okay, new project, right? Now I'm going to do something known as experiment one. Okay, this is going to be the folder within Sanjay. I have made one experiment one, and the location I am going to select as folder. Okay, Sanjay experiment one, right? So this is the name of the new project, and this is my working directory. Under Sanjay, you have experiment one, two folders. Okay, then am going to click next. Okay, so these all default values. Okay, this is Verilog. Preferred language is Verilog. You just have to see, ensure that it is Verilog A. Verilog, sorry. So once I have done that, I'll press finish. So this is going to open up a window like this. So let me maximize it. Okay, okay, so experiment one. So I'm going to do a right click on it, and new source. Okay, I'm going to make a Verilog module. So I'm going to select a Verilog module. Okay. Now I am going to make a sample circuit. Sample circuit. You will give a different name once you are done with the sample circuit testing, like sample circuit. Okay, I am going to press next. So this is the module name. Now ports. So I'll just give in A is going to be input, B is going to be the input, C is going to be the input, and I have got X and Y as outputs, right? There are two outputs available. I am going to press next. I'm going to do finish. So this will generate me the right Verilog code. I can close this design summary thing. So this is my module. SAM circuit is the name of the module. Input ABC, output. Okay, I can some when I'm writing the code, in case I need to do some change, you don't have to go back again, set the pins there. You can change the code input and output here also. So that is not a problem. Now I am going to define a wire. That is wire W1. Okay, so I have defined one wire here. Now I am going to have AND gate, which is G1, name of the gate. Output is going to be wire 1 and inputs are going to be A and B, right? So this, now I am going to have a NOT gate, NOT, which is G2. Okay, and that is output is going to be Y and input is going to be C for that, right? And then finally I am going to have an OR gate, right? For that I am going to have G3 and I am going to have an OR gate. Output is X, and then I am going to have OR of W1 and Y, right? So I am going to do this, right? So this code is now saved. Okay, I can save this code, and then now I need to test whether this is working fine or not. Okay, so you got to select simulation. Okay, this is the mistake which we do. Okay, many times we don't select this, we got to select simulation and this. Okay, now we are going to do simulation and sample circuit. So these two selections are very important. So you do that, you will get I simulator. So we expand that. First we do a behavioral check, right? So in case there is any syntax error, it will show the syntax errors. So there is no syntax error. Okay, then the next is we are going to do the behavior. We're going to simulate the behavior of this circuit. So once you click that, so another window would pop up. I'm going to give a document also, so you can refer to that also once you go through this video. Now see, there are it is no values have been given, some graphs, so we got to test the thing. So I am going to value, I'm going to select value, right click it, force constant. I am going to put a force constant value of 0 for A. Okay, I am going to put say uh, force constant, sorry, uh, force constant. I'm going to put 1 for B. Okay, see, once I give okay, these values will not change now. Unless you run, it will not change. Okay, so force constant, I'm going to put a 0 value to 0. Okay, so I have given these three values. These are outputs, so we cannot give any values to these things. So I am going to do something known as run all, right? It will run for 1 microsecond. The time is specified here. So I'm going to run it. So I have got some output. Now A is 0, B is 1, C is 0, X is 1. Okay, uh, uh, X is 1, Y is 1, and W1. W1 was AND of A and B. So 0 and 1 AND, you are getting 0. and x is 1 because that is y is 1 because that is not of c, so that 1, and x is or of y and c, so you are getting 1. So you see these are the zeros and ones. That will be slight variation between 0 and 1. You may not be able to visualize here. Once we give a different condition, we will be able to visualize that. Okay, in the next condition, okay, let me now do a force constant. Okay, I am going to force c uh, force constant, force to a value of 1. I am giving 1. Now if I give 1, even the y is going to be 0 and output is going to be 0 now. So I am going to do run all. So you see these are changed. The output has gone to 0. Now if I want to see the previous also, I can press this zoom to full view. Okay, this was that initial junk value. This was the first condition. This is the second run which I have done, right? So I can see that how values have changed from 0 to 1. It's very much. So I can do one more. Say I go to, and this time I'm going to put a also 1, force constant. I'm going to put it as 1. Okay, and I'm going to run it here, right? So now this is the third condition, you see. So for different test conditions, I can verify my results. Okay, so this is how I'm going to test my circuit. Okay, this you will do this. You will also do one more thing. So I'm taking this window right here. Now I'm going to select the sample circuit. Okay, and I'm select it, and I am going to do a new source, add new source. Okay, now this time I am going to do Verilog test fixer. Okay, now once I do Verilog test fixer, I'm going to give a name also, that I'm going to give it a sample circuit test, right? Okay, sample circuit test. Okay, it is asking select a source. So a sample circuit, I'm going to make a test circuit for this. So sample circuit. Okay, next, finish. So now I am getting a sample circuit underscore test. This is another Verilog A code. Okay, it is based on that. Now if you see here, it is initially conditions is 0 ABC, wait for 100 nanoseconds. Okay, then again it says end. Now you can add many test conditions here itself. So let me delete this, right? So I let me do it only for 10 nanosecond. Okay, this means wait for 10 nanoseconds. Okay, then I am going to copy this. Let me copy this also, copy this and paste it here, right? I am going to give 0 0 1 one test condition, right? Let me delete this and put a space here. This is better, right? I am going to copy this. I'm going to press an enter and again put it here. Now I'm going to give another test condition, 0 1 0. I'm going to copy this. I'm going to finish this, paste it here, and I'm going to give one more test condition out here, right? So I can keep doing this and make as many test conditions you want, right? Since there are 3 bits, if you want to do an 100% check, you can put all the 8 different combinations as test condition. Also, once you have done with this, see, when we run, it will run for 1 microsecond, right? So that is the default setting. But after this, if you want to finish, you can write this as dollar finish, right? If you don't do this, it will keep running for 1 microsecond. With this last condition, see, in 30 seconds, now I have put 3 or 4 conditions. So 30 to 40, in 40 nanoseconds, I am getting my desired results. But if I don't write this dollar finish, it will run for 1 microsecond, right? It will with this condition, with the same last condition. So I have put a dollar finish. Now again I have to simulate this. Again, remember, you have to select simulation, you have to select the sample circuit, and then do a behavioral check, right? I am doing a behavioral check. Okay, it's passed. Now I'm going to do the simulate behavioral. So I am getting this test here. When I default the waveform window, if I can, I'll see a waveform out here. This is the last condition. If I want to see all the conditions, I do zoom to full view. So I have given four different conditions. See, so the output for the four test vectors which I have given is available here. You can test it out for all the eight different kind of test vectors. Okay. So now what all have we studied here? We know how to make a circuit, how to make a test it using the force constant method, and then we'll also create a test bench. Okay, to create a test bench, it's pretty easy. You just have to select that, right click, create Verilog test fixture. You will get it automatically. It will generate the sample circuit. Once it has generated the sample circuit, just copy and paste the conditions out here, right? Dollar 10, this stands for wait for 10 picosecond 10 nanoseconds. Okay, because no, if you see the waveform, these are all 10 nanosecond, right? You can give 100 also, whatever it is. Okay, so at least 10 we give, we see the proper waveform. So I have shown the demo, and you got to do for the majority circuit and the parity generator, right? You got to do it and show it to your instructor. Okay, thanks a lot, and do well.